Hello friends, in this lecture we will see curve point drive method in 4 axis, and we can do in the same way for 5 axis as well. So this curve and point drive method is available in multi axis. So first of all, see, for this MCS, my Z is in up direction and X is along the axis. So fourth axis will be A axis. So I'm going to use this same MCS, and first I'm defining my part. So this is my part, okay, and blank I'm using bounding cylinder, okay, and my axis is this along X and reset, okay, and I'm just defining the offset. Diameter is so 40.2, okay. The thickness is a little bit extra, so this distance it will cut, or zero point 0.4, so zero point 0.2 is a thickness, because my tool will work over this curve, okay. Show blank, I don't want to display this blank, okay. Okay, now tool, I'm using a ball mill. Double click over it, and the tool is a taper angle and flute length and length, and I'm adding a holder. So go to this library and you can retrieve the holder from this library. Okay, so this is my tool, okay. Now from create operation and this multi-axis, I'm using variable contour, or you can select, these are for the tube, so we will see this. So I'm going to click this one or this one. We can change from drive, and my program location is folder, and this is my tool. Workpiece is this, and my method is finishing, okay. Now here we have to define, I'm going to define my cut area. So this face is my cutting area, okay. And from this drive method I'm using this curve point, okay. Now select the curve, so my curve is connected curve. Select this and add. Second, add. This third, add. And the fourth one, add. And I want to add this one also. Add a small circle is there. Now okay. And projection vector will remain same for the tool axis, and my axis is normal to drive, okay. My drive surface is this outer cylindrical surface, and for strategy no need to change this strategy, it is okay. And tool I have already selected. Strategy, if you want to add the multiple depth, that time we can use or generate it. Okay, and verify it. It's a little bit slower. And in 3D dynamic, it will work over the curve. So this material is cut only 0.2 mm, which we have defined in blank. Click OK, and again OK. And I want to create this same for this text. Okay, I have created this text and place over this face with under curve we have text, so I have used that curve, that text. So create operation on the same, I'm using all the parameter. My cut area is this, and change it to curve endpoint, and my curve is this. Add second curve, middle click to add new set. Use middle button to add new set. Okay, and one more curve. Okay, this add, and I want this curve as well. Okay, and part stop, if you want to left and part stop. My projection vector is along the tool axis, and from geometry workpiece we have already defined, and my axis normal to part, just generate. And see, the non-cutting move is very regular. So for non-cutting move and common clearance, I'm using a cylinder. So select this cylinder, and center point is this, and radius I'm using 50, and my vector is this. See, it is big, so 40. Look, this circle is my retract value. Generate. Okay, so see, this is the 40 diameter. Okay, and let's see this preview. Now play it. Okay, so this is the curve point drive method for multiple axes. Okay, and okay. Now I want to add the machine, so go to this machine to view and right click over this generic machine and add it, and retrieve machine from the library. Click here, and I want milling machine. Okay, and I'm using 4 axis milling vertical A table. So my fourth axis is X A, so I'm selecting this one. Okay, and you can assemble it. Okay, as we do in assembly, we can do same placement method in this, and close it, and okay. So this is the machine, and it is properly placed here, and see, my tool is on workstation. Now select the operation, this is my operation, and simulate machine. See, here we have X, Y, Z and A axis, and play. Okay, the tool path is not visible, so just stop. Okay, stop it, reset machine. And if you want to use this material removal, we can add this. from here we can show this display toolpath. So toolpath will display, and now play. Okay, it is working. My A is moving. Okay, now I want to reset this. Click here. So click this one, and here machine simulation. Here we have material removal. If you will enable this and hide this display toolpath. Now I'm going to play. See, it is cutting. Material is removing now. X, Y, and Z. And see here my NC programming is like this linear and this type, है ना? So just stop it, close, and this my method is tool path based simulation, and I want machine code simulation. So first I'm going to generate the CNC program for this operation. So click it and post process, and this is my post processor. Okay, this is tool path program. This is CNC programming. Now close it. First you need to generate. Now I'm going to this machine simulation, and here I'm changing this to machine code based simulation. Now that CNC program will come in this window. Here it is. NC program. See, this is the program, CNC program, and display. It is working, and here which block it is working you can find here in this CNC program. So here is the speed. You can increase the speed of this simulation. X, Y, Z, and A. My stock is a little bit smaller, so this folder is clashing with the chuck. So no problem. Just increase this blank, and if you want to see the clashing, you need to switch on this machine collision. It will show you what other parts are clashing. So hope you understand this operation.